Very good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Good. Maybe during the afternoon session, it will be tedious to listen to me. Right. I'll try to interact with you then and there. And I hope you all are very much comfortable in using chat in Google Meet. Am I right?
Yes, sir.
Yes, sir.
Yeah. Shall we say good afternoon in the chat so that others can see it now? Wow, super, excellent, excellent. Thank you, everyone. So please give me the cooperation in the similar way. I will try to make you not to sleep. కొంచెం subjective will always be bored. Since it is going to be similar to GATE class, ரொம்பல பயப்பட வேணாம். I think when you are not comfortable with the content or when you are not comfortable with the flow, you can raise your hands so that I can interact individually as well as I can change my flow. And do you all know what is the topic today? Yes. What is the topic today? Especially, I'm going to talk on sensors as well as I'm going to talk on industrial instrumentation. These two are the topic. Right. Actually, these two like a ocean. We instrumentation engineer should be very much confident about these two things. This is very basic, and I will be touching from the basic. Maybe I'll be moving on to some specific sensors, some specific transducer, but still, certain basics are most important. Well, do you all know what is sensor? Anyone, please unmute and tell what is sensor. Are you all comfortable with English, or you want me to interact in Tamil as well? Are you all okay with English? Hello? Guys? Regular class மாதிரி இருக்கீங்களா? You think you are in regular classes? You should not interact with me. Have you studied the sensor before? At least say yes or no. Which year you belongs to? Second year? Third year? Any second years are here? Super. So there are second years. And is there any third years? Don't worry, I don't question you. Any third years? I think starting roll number like 19 or 30 years. Am I right? Good. So you people are scared to unmute. Maybe your circumference or your neighbors are not silent over that. So I presume that you are listening to me. Right. So I'll go one by one. Sensor. Sensor, which means that states you the thing that used to sense. ஏதோ ஒரு விஷயத்தை நம்ம சென்ஸ் பண்ணோம்னா அதுக்கு பேர் சென்சார். ஸோ வி ஹியூமன் பீயிங் டூ ஹாவ் சம் சென்சார்ஸ், ரைட்? யுவர் ஐஸ் ஆர் சென்சார்ஸ், யுவர் நோஸ் ஆர் சென்சார்ஸ், யுவர் இயர்ஸ் ஆர் சென்சார்ஸ், யுவர் டங் as well as your fingers, your skin. So these are all the sensors. What it sense, that is the matter. What it sense? Your eyes will sense the light matters. வெளிச்சத்தை நம்மளால பார்க்க முடியுது இல்லையா? when I sense some light matters, so of course that particular sensor is active. So when you smell something, which means when you smell something, that particular sensor is active. When you hear, I'm talking to you and you could able to hear, no, that is also by means of sensing something. So this information what you receive, maybe by means of a signal, by means of a taste, or by means of a light, you are getting something, no, that I call it as physical signal. Carefully check it. Physical signal. So there are so many things you know about the physical signals. That is, for taking as an example, temperature, pressure, humidity, flow, and level. These 5 different parameters we generally measure in any industry. Right. So when I sense my temperature, pressure, humidity, flow, and level, I cannot directly say that this is the temperature 5 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, and all. Because the sensory information is passed to certain computers. நம்ம இங்க என்ன சென்ஸ் பண்றோமோ அதை as such physical quantityயாவே எடுத்துக்க முடியாது, which is not at all possible. So this I need to convert into electrical quantity. Right? So this is my physical quantity, and this information should be converted into electrical quantity. So that what I can do, I can do the process, I can do the measurement, I can even take it for further processing. So this is my electrical signal. So this is the physical signal, and this signal is to be converted into electrical now, which we will be doing by means of transducers. So when I comes under the topic sensor, I will not only study about the sensor, I should also study about the transducers. Right? What these transducers do? This will convert a non-electrical quantity into electrical quantity. It is like converting your signal from one domain into another domain, like your transforms this do. But especially what it do, it will actually convert a non-electrical signal into electrical signal. That is the matter. Don't confuse. So the matter is, it can be electrical to non-electrical. Similarly, this can also be converting your electrical to non-electrical, like physical quantity electrical quantity conversion மாதிரியே this will also convert electrical quantity into physical quantity. This is also possible. So based on this, the transducer is classified into certain types. Major types I will just represent, and I will get into one by one. Measurement ke நம்ம ஒண்ணா பார்ப்போம். First, let us go with active and passive. This is one type, active and passive. I hope you heard about this. Active sensor, passive sensor. So what is active and passive? The active is the one which do not need any external sources. So there are some people in this meet. I think there are around 16 people are here. So I don't expect that all 16s are interested or volunteered to attend this meet. கரெக்டா இங்க இருக்கிறவங்க எல்லாருமே வாலண்டியரா வந்து ஐ ஷுட் லேர்ன் சம்திங் நியூ அந்த மாதிரி ஒரு மைண்ட் செட்ல இங்க வந்திருக்குமா அப்படின்னா ஐ டு நாட் நோ. Right. So there are some force which induced you to sit in this classroom. எய்தர் உங்க ஃபேக்கல்ட்டியா இருக்கலாம், பேரண்ட்ஸா இருக்கலாம், ஏன் யாராவது ஒரு ஃப்ரெண்டு டே நான் தனியாக அட்டன் பண்றேன் ஜஸ்ட் கம் அண்ட் ஜாயின் வித் மீ. ஸோ யுவர் ஃப்ரெண்ட் மே அக்கம்பனி யூ. ஸோ வென் யூ இன்டியூஸ், வென் த எக்ஸ்டர்னல் சோர்ஸ் இன்டியூஸ்டு ஓவர் யூ, வி ஆர் டூயிங் நோ தட் இஸ் வாட் பேஸ் யூ. அதே நேரத்தில் தேர் ஆர் சம் பீப்புள் ஹூ வாலண்டியர்டு நான் படிக்கணும், ஐ ஷுட் லேர்ன் நியூ திங்ஸ். So you volunteer, no, there is no source, your internal source which do. So that is what active. So active, passive. So there are category. We don't want to go in depth one by one. I will just list them. You just make note of it. I don't want to go with the PowerPoint presentation. I will share this content to you. You can keep it with you, right? When I present through PowerPoint presentation, my students used to sleep. So I don't go with the PPT at all the time. So this again classified into primary and secondary, analog and digital. One is inversible transducers. So which we call it as inverse transducers. Similarly, this is about the type, right? So all these types are once again classified into, right, based on the nature of sense. So I may sense something, no, based on my natural characteristic. This is once again classified into resistive transducer, inductive transducer, capacitive transducer, hall effect sensors, and lastly piezoelectric transducer. So these are all the different types of transducers. So we are going to in depth one by one, not much more than one by one we will go, right? So resistive transducer, what it do? So when you do something, for example, you take when your parents are cooking in home, they will have a vessel, no? So that vessel will have some handle. So on the handle பார்த்தீங்கன்னா they will have an insulator, non-conducting material எல்லா ஹேண்டிலையும் இருக்கும். Why? They don't want the heat to be conducted to their hands. They need to resist the flow. So each and every metal, conductor, semiconductor or non-conductor will have some characteristic. So we are going to use that characteristic to measure our information. That is what we do, resistive. Similarly, inductive, you know all this, right? Capacitive, all of it is electric. So இதை யூஸ் பண்ணி தான் we are going to do. So first let us go with resistive transducer. One by one போவோம். I would like to go with resistive transducer first. I'm sorry. Okay, let us go with resistive transducer. So here, this resistive transducer, especially in your gate, they have strain gauge. Sir, I'm not going to tell more number of concepts with strain gauge. You know, we have so many syllabus to be covered. Strain gauge is one of the beautiful concepts. Easier புரியும். அதுக்காக தான் நான் ஃபர்ஸ்ட் எடுத்துக்கிறது ரெசிஸ்டிவ் டைப், எஸ்பெஷலி ஸ்ட்ரெயின் காஜ் எடுத்துக்கிறேன். ஓகேங்களா? Because you need to solve some problems. Carefully listen to me. Strain gauge. What is strain gauge? We have to check that too. Strain, stress, இந்த ரெண்டு விஷயமும் கேள்விப்பட்டிருப்பீங்க. Strain, stress. So what it means? Strain and stress are related to mechanical energy. Strain and stress are related to mechanical energy. Appo my transducer should convert a non-electrical parameter into electrical parameter. Strain என்ன parameter? Strain is a mechanical energy. So I need to convert, that is my transducer should convert a mechanical strain into electrical strain. So what is the role of my transducer here? Mechanical strain into my electrical strain. So mechanical strain into electrical strain. Strain என்ன? ரொம்ப ஸ்ட்ரெஸ் போட்டுக்காதரா, ரொம்ப ஸ்ட்ரெயின் பண்ணி ஒர்க் பண்ணாதரா, கேள்விப்பட்டிருப்போம். The deformation, என்னுடைய natural characteristic will remains with me, but my appearance, there may be some change in my appearance. For example, you may have an eraser in your hands. No, when you press your eraser, you see, when you apply some pressure over it, what happens? It will deform itself. It will deform itself. So that is what we are going to consider to convert it into electrical quantity. So when the mechanical strain, my, for example, let me take del L by L. The L is my natural length. When I apply some pressure or force over it, this will deform, no? So that deformation, how much there is a variation, that is what I represent it as del L. So என்னுடைய strain எப்படி இருக்கும்? Del L by L. Similarly, when I do this, what happened? There will be change in my electrical strain. So electrical strain in the sense, what is the type we have taken? This is resistive. So when there is a deformation in my shape, that will obviously disturb my conductivity, that will obviously disturb my resistivity. So that I supposed to make it as del R by R. அவ்வளவுதான் சார். இந்த formula we'll be using for long period, right? So that is what I especially stress on this. அப்போ என்னுடைய transducer is strain gauge, my transducer is strain gauge. What it do? It will convert the mechanical strain into electrical strain. அப்போ என்னுடைய factor எப்படி இருக்கும்? How I am going to perform, that is depends on my output as well as my input. என்னுடைய performance எப்படி இருக்கும்? It is depends on output as well as input. So that I supposed to make it as gauge factor. My gauge factor is GF. Generally we represent a gauge factor as GF, which we represent as my electrical strain. What is your output? Your electrical strain is your output divided by your mechanical strain. So mechanical strain is your input. That we have to make it like del R by R whole divided by del L by L. So this is what which will tell you about your gauge factor. Right. So directா ஒரு formula ஒரு problem பார்க்கலாமா? Because when I use these things, we should also concentrate on gate questions. Right. So shall we go for one problem? Are you all with me? Then and there I told you, no, I will check you all. Shall we go for one problem? At least one response in the chat, I can post the question. Good. Super. Thank you. Roll number 16. Take the problem. The unity ratio. Sorry. The strain gauge 1 second. Yes. The strain gauge, I just check the chat. The strain gauge is attached to a bar of length 20 centimeter, which is subjected to a tensile force. இப்போ என்ன பண்றோம்? Carefully check in. Please check the chat. Okay, I do one thing. I will also post it in our shared window, no, so that the people, those who not able to see it, may able to get it. Yeah, this is the question. Easiest question. Sir, I'm not going depth. There are some complicated questions are available in the gate, but since we are all beginner to get, no, when you are not able to understand it, you will not continue. So I'm taking the most easiest one. Look at here, what is given? A strain gauge is attached to a bar of length 20 centimeter, which is subjected to a tensile force, which means what? I have a bar. இந்த மாதிரி எனக்கு ஒரு பார் இருக்கு. So this is subjected to a tensile force, right? So similarly, the nominal resistance of the strain gauge, என்னோட strain gauge ஓட natural resistance என்னவா இருக்கு? This is 100 ohm. So in the strain gauge ஓட length is 20 centimeter and the gauge resistance is 100 ohm. The change in the resistance and elongation, when I apply some force, the resistance of this as well as this is getting elongated, maybe compressed or maybe expanded, no? So that they are valuing it as 0.35 ohm as well as 0.2 mm. 0.2 mm. So find the gauge factor. அவ்வளவுதான் சார் question. Very, very easy one. What we have to do? Very good. Somebody have given the answer. Excellent. So it's a direct formula. Very good. Anybody else is getting the same answer or is there any change? Is there any change in the answer? Anybody is getting different answer or you are getting the same 0.35? Okay. So let me solve this. If you get any doubt, you can raise your hands. So what is the formula for your gauge factor? My gauge factor is very simple. It is a formula like del R by R. I already given you del L by L. Now, is the values are given? That is the matter. Let us check whether the values are given. Let us check. So values are like, you see, L, which is length, that is given here. Similarly, del L, that I will come to later. Resistance value, is the resistance value given? Yes, it is given. Right. So I have L, I have R, both del R, del L. Deformation happens, no? That is given, del R, del L. Now this I am going to take. What is your del R? My change in resistance is 0.35 ohm. We forgot to use this. Divided by, actually this is 100 ohm, divided by, what is del L? 0.2 mm divided by 20 centimeter. So meter to meter cancelled. I take this for your advantage. Meter to meter, cancel. Ohm to ohm, cancel. So I no need to worry about the unit of ohm, but I need to worry about the centi as well as milli, which represents what? 0.35 divided by 100 whole divided by zero point 0.2 into 10 to the power minus 3 divided by 20 into 10 to the power minus 2. Centi represents 10 to the power minus 2 and this represents 10 to the power minus 3. If I cancel what I will get? I will get in denominator I will get 10 to the power minus 1 alone I will get. Right. I will proceed further. Please carefully follow me because we make mistake only at this point. 0.35 divided by 100 whole divided by zero point 0.2 into 10 to the power minus 1 divided by 20. Now what happens? What is the value in your numerator? The value in your numerator is 0.35 into 10 to the power minus 2. I am just taking this into the numerator of your uppercase 0.35 into 10 to the power minus 2 whole divided by what I do have here. I have 10 to the power minus 1. 0.2 divided by 20 is what? If you have calculator, you can compose, or otherwise you can just make it as 2 into 10 to the power minus 1 whole divided by 20. Whole divided by 20. So this time what happens? This time what happens? I have one more 10 here. See, I am doing fifth standard calculation. When you directly cancel the things, you will directly get the answer. But by the time you should not make mistake. That is why I am carefully doing it. You see, 2, 2 cancelled. I have 0.35 divided by 2 divided by 20. So this I can make it as 2 into 10 to the power minus 1. Are you all agree? 2 into 10 to the power minus 1 or otherwise we can easily make it like this. You may get it better. 1 divided by 10. 1 divided by 10. So if you take it, what happens? What is the end result? Now you tell me 26, roll number 26. What is the result? Hello? Very good. So where did you make mistake? I just guessed this. You would have forgot to represent the unit. That is the problem, sir. Am I right? You missed out milli as well as centi. Am I right? 26? Good. So let us be careful from this moment onwards. That is what the twist they will do. They will not make you to think more. Of course, you see, you should be confident as well as you should be very very cautious. ரெண்டுமே வேணும். ஏதோ ஒன்று மிஸ் பண்ணிட்டோம்னா we will lose the marks because there will be a negative mark in your case. ரொம்ப ஈஸியான கொஸ்டின் பட்டு பட்டுன்னு போட்டோம் ஈஸியாக பாயிண்ட்ஸ் வந்துடுச்சு பட் the options are, let me also represent the options, represents options ஏன்னா இங்க ஆப்ஷன் இல்லாதனால தான் கன்ஃபியூஷன்ஸே is it not? So when they represent the options, what you will get? The options are actually the given options are A is 2, B is 3.5, C is 10 and D is 100. So this is one separate options they used to give. How they are making the options, that should also be told. No, look at here, they are making these two from the length 20, this 3.5 from the resistance 0.35, this 10 they are making it from ohm, this also they are making it from ohm. So they are taking the option. This is one. The second one, in the similar case, they will give another option 0.35, B 3.5, C 35 and D 0.035. This is what it will confuse. These two may be the option where we will be confusing. So this is case 1. So you got to know about stain gauge and its property. Now, sir, this is okay, sir. Stain gauge, it is okay, sir. So how it is used to convert? So let us test upon one more factor. I would like to adapt with one more factor. So let me change my slide. So if I use stain gauge directly, I don't benefit much. I have to adapt with something else. So what is that? That they are naming it as bridge. So they would like to construct a bridge, right? This bridge which will help them to identify. So on the bridge எப்படி construct பண்ணிருக்காங்க? I will explain that. Okay. So usually what they do, they will take a bridge like this, and you are going to name this. I'm not going to name this. What you call it as? You have to name this. I believe that I'm not boring with the same content you already know. So if the contents are repeated, please you let me know so that I can change my content. What it is? Any idea? Very good. It's a bridge. The bridge எதுக்கு யூஸ் பண்ண போறோம்? அதுதான் மேட்டர். You believe it or not, this is a wonderful science you're supposed to know. Sir, not only in gate, sometimes people also getting the instrumentation topic like LVDT and strain gauge along with midstone bridge. These three they used to test in IAS examination as well. IAS examination as well. You know, the concept is a beautiful one. So how many resistance are there? How many resistance are there? R1, super. R1, R2, R3, and R4. We have four resistance. So, what is the purpose of these four resistance? This is like the bridge is very much beautiful one. You check. I am connecting with the source. No, this I call it as VS. So I supposed to test my output. That is output of this bridge. We have to test. No. So what they are doing actually, they are taking it to the open loop circuit like this. They are opening it. These 2 points are opened up, which means the resistive in these 2 points will be like infinite. But the beauty what here you check it out, the flow of current is generally happen through this way as well as through this way. The current will try to flow between these 2 points, right? Because these points is very open. When the infinite resistance happens, nothing can flow through this. So the flow happens only through this, right? So I am using the source now. So output of my bridge. I don't want to go in depth more. The output of my bridge will be equal to the Wheatstone bridge will be equal to my input source Vs. Excuse me. My output of my bridge will be equal to, the terminologies will be different ma, don't confuse. நான் சொல்றது வந்து நமக்கு ஈஸியா இருக்கும். நான் வந்து ப்ரிப்பரேஷன் பண்ணும்போது I represented like BR. Your faculty may have a different representation. Sometimes your textbook may have a different representation. Don't worry about that. So my input source, my source, voltage source that I am connecting, it can be either input or current. That is not a matter right now. Right. So this is passed through two resistance. No, the difference between these two will be the output. The difference between these two will be the output. Generally, they will be making it as the total resistance of this, which they are generally making it as, right. I let me take the general representation R2 divided by R1 plus R2. This is through one point. VR, VR, VR. Actually, the voltage given to both the line remains same. So I'm taking Vs as common. Here in this line, R2 divided by R1 plus R2 and subtracted with my R4 divided by R3 plus R4. Right. So this is what the general diagram. Now, in the concept, I'm going to adapt with resistive transducer. என்னுடைய கான்செப்டுக்கு நான் யூஸ் பண்ணிக்க போறேன். ரைட்டா? எப்படி யூஸ் பண்ணலாம்? Let us check how to use this. I'll tell you. I'm sorry, excuse me. So how I am going to use that? Let us check. So I have 4 resistance, no? But I am going to make all the resistance are same. R1 is equal to RZ is R2 is equal to R3 is equal to R4. So what happens to my output? My bridge output will be equal to what? We check it out. R2 is same R divided by 2R. Let us commonly make it as R. If I make it like this, what happened? R2 is equal to R1 by R2. That is R by 2R minus R by 2R. So output of this bridge will be equal to what? Any idea? Can you guess? Output என்னவாகும்? Very good. The output will goes to 0. அதைத்தான் நான் இங்க கான்செப்டுக்கு யூஸ் பண்ண போறேன். Right? The output will be 0. So this I would like to pick it for my consideration. So what I'm going to do, the output will be 0. Output 0 ஆகிறதுனால எனக்கு என்ன benefit? I'll be gaining nothing, no? So when I use it, I'll be gaining nothing. So I'm going to make a small change. எனக்கு எப்பவுமே output will be 0 if the resistance are same. So let me use the same that instead of taking one resistance as equal to the others, I would like to make it as a change in resistance. அப்போ இந்த இடத்துல ஒரு change in resistance when I keep, what happens? The equation will turn better. எப்படி மாறும் அப்படின்னா, instead of 0, I'll be getting some output. This is logically true. Don't go mathematically. Please look into it logically. So என்ன ஆச்சு? 4R when they are same, I am getting 0. So I have 3 resistance that are same. ஒரே ஒரு resistance alone is different. If I need to get 0 out of this, எனக்கு bridge output 0 வேணும்னா இந்த இடத்துல R2 நான் என்ன பண்ணணும்? I should make it equal to others. So we have to adjust this to get the same. So this logic they are making. So what happens? So instead of keeping one particular resistance which is adjustable, that is part கேள்விப்பட்டிருக்கீங்களா potentiometer, instead of keeping potentiometer, I'm going to keep the strain gauge. The previous ஒரு டாபிக் படிச்சோம் இல்லையா? When I apply some force, that will change the resistance, and based on that I will get some output. No, that gauge I'm going to replace at this point. அவ்வளவுதான் சார் கான்செப்ட். இது அப்ளை பண்றதுனால I will get another equation. Equation solve பண்ணா we'll be losing more time. So just I will tell you the logic and I will directly give you the equation. Right? What happens? 3 resistance are same. 3 resistance are same. What are those? R1, R3, R4. The 3 resistance are same. The fourth one is also same. The fourth one is also same. It is like a total resistance. There will be some deformation. There will be some deformation. When I apply force, that's the matter. When I apply force, if I don't apply force, which means what? Force is not equal to 0. என்ன ஆகும்? என்னுடைய resistance value, that is when I apply force, resistance value will be resistance actually available in my strain, that is in my gauge. Along with there is some deformation, no? So R என்னவாச்சு? R plus del R convert ஆயிக்கும். R is my resistance, del R is the deformation that I am getting through some strain, that is through some force. So R energy R plus del R convert ஆயிடுச்சு. So this I have to consider for my bridge equation. Right? When I consider for my bridge equation, what happens? My equation will be turned into my V bridge will be equal to Vs into, actually that R will be R plus del R. அப்ப எனக்கு என்ன ஆகும்னா denominatorல இருக்கிற R's எல்லாமே சேர்ந்திருக்கும். Totally how many resistance I do have? I have 4 resistance. But one resistance alone will be changing, no? So that will be your del R. So this is what the general equation. So when I apply the values, previously we had it, no? R2 by R1 plus R2, R4 by R3 plus R2. When you apply, your R2 alone changed. When you apply, there are steps. ஒரு ஸ்டெப்ஸா போட்டுட்டு இருந்தா நமக்கு டெரிவேஷன்லயே போயிடும். We will not be getting more problem to solve. அந்த டெரிவேஷன்லயே போறதை நம்ம வேஸ்ட் பண்ணிடக்கூடாது. So I would like to give some problems to be solved. So I would like to target over this. Directly I will give you. This is an input source. Source voltage கொடுத்திருக்காங்க. Del R is change in resistance. My actual resistance, remaining common resistance இருக்கு இல்லையா, that is 4. So this is actually they will be making it as generally இத ஒரு sentenceல சொல்லணும்னா what will be the equivalent when I represent by using the sentence. My bridge resistance output will be my input, the quarter of my resistance alone changing. So the quarter of my resistance alone changing with respect to electrical strain. இப்ப புரிஞ்சுச்சா? இத மனப்பாடம் பண்றது ஈஸியா? My input, my change in electrical strain. என்னோட electrical strain கொடுத்துட்டேன், என்னோட input voltage கொடுத்துட்டேன். இது என்னோட bridgeல 1/4 பார்ட்ல தான் சேஞ்ச் ஆயிருக்கு. அதைத்தான் சார் இப்படி எழுதிருக்காங்க. டெரிவேஷன்ல வர்றது தியரியில வர்ற லாஜிக்கோட மேப் ஆகும். So just to memorize this. I hope this is good to you all. Am I right? Right. Now once again ஒரு டைரக்டா ஒரு ப்ராப்ளம் சால்வ் பண்ணுவோம். அகைன் அடுத்து ஒன்று கொஞ்சமா ஒரு ஸ்மால் வேரியேஷன் கொடுத்து ஒரு ப்ராப்ளம் சால்வ் பண்ணுவோம். ஓகே, let me give you the problem. One second. Am I going the right way or am I going fast, slow? Any comments? Because I am new to you all. உங்களுக்கு நான் புதுசு, எனக்கும் நீங்க புதுசு. Will you proceed in the same manner? Yes or no? Okay. So I have given the question in the chat. Also, let me represent the same in the presented screen as well. Direct questions once again. Or direct question. Or indirect question. Not indirect. We have to predict something. That is, we have to identify something. அவ்வளவுதான். ரொம்ப காம்ப்ளிகேஷன்லாம் கிடையாது. The unity ratio quarter bridge strain measuring circuit produces an output of 1 millivolt for the strain of 500 microstrain. When the bridge excitation is 4 volt, அவ்வளவுதான் sentence முடிஞ்சது. So how many parameters are given is the matter. Direct questions நானே சொல்லிட்டேன். நீங்களும் you don't keep it in your mind. நான் சொல்றத அப்படியே வச்சுக்கிட்டுலாம் ஒர்க் அவுட் போடக்கூடாது. எப்பவுமே when I tell you, you have to read the sentence. A unity ratio quarter bridge strain measuring circuit produces an output of 1 millivolt for a strain of 500 microstrain when the bridge excitation is 4 volt. The gauge factor of the element is dash. அப்போ அவங்க என்ன சொல்லியிருக்கிறாங்க? They have given certain clues. We have to predict the clues. எடுத்த உடனே சொல்லியாச்சு, when there is a sentence called bridge, which means I am going to work on bridge. Bridge circuitல நிறைய இருக்கும். Bridge circuitல different resistivity இருக்கும், same resistance இருக்கும், எப்படி வேணா இருக்கும். There will be a lot of difference in the circuit. So you should not think much about it. ரொம்ப கேர்ஃபுல்லா இருக்கணும். அதுதான் விஷயம். அவங்க என்ன கொடுத்திருக்காங்க? The unity ratio. What do you mean by unity? Can someone சொல்லுப்பா? What is unity? What unity represents? The unity represents constant. That is, if it is 1, if it is 2, if it is 3, the unit represents unity in the sense எல்லாருமே யுனைட்டடா இருக்கணும் அப்படின்னு சொல்றோம் இல்லையா? The bridge resistance are same. How much it is same? A quarter bridge, which means 1/4 part is not the same. Remaining things are same, which directly given you the option. So this is, we have unity bridge. The quarter bridge which represents one resistance is the different. Right, that resistance is connected with what? A strain measuring circuit, which produces an output. What is the output? The Wheatstone bridge output என்ன? 1 millivolt. Let us take it. The 1 millivolt is the output. அப்போ we got Wheatstone bridge oda output. VB we got. The next one is VB we got. What is this? The strain we got. And the next one, 4 volt we got. Right? So with all this information, we have to identify gauge factor. Okay, we have to identify the gauge factor. We keep this and let us proceed. Okay, so let me take it to the solving. நீங்க இப்ப solve பண்ண வேணா, I'll solve it. Even if you try, this is little bit, yeah. I'll give you the clue to solve this. Given, sir, I'll give you the clue and then you solve it. What is given? Carefully take it. Do we have the bridge output? Quarter bridge output do we have? What is that? What is that quarter bridge output from the given question? It is very good, 1 millivolt. And next one, what is given next? It is quarter bridge. So we have to take this equation. No, we have to take this equation. The next one, what is given? What is the excited voltage? Excitation voltage, source voltage என்ன கொடுத்திருக்காங்க? The excitation, bridge excitation voltage is it's 4 volt. Very good. Appo I got this. But here you see they have given the strain not in terms of resistance. It is a mechanical strain. It is a mechanical strain. அப்போ கொஸ்டின் என்ன கேட்டிருக்காங்க? gauge factor கேட்டிருக்காங்க. இதுல gauge factor இருக்கா? Do we have gauge factor in this equation? Do we have gauge factor in this equation? GF is it available? What is the formula for your GF? In the previous slide I told you, no? GF is equal to Do you remember? Del R by R whole divided by del L by L. I hope you do remember this. அப்போ எனக்கு ஸ்ட்ரெயின்ல சேஞ்சஸ் என்னன்னு சொல்லிட்டாங்களா? Del L by L is given. You see, del L by L is given. Del L by L is given. Right? So, del R by R, is it available in this equation? So that is available in this equation. Del R by R is available in this equation. So what I can do? I can replace this del R by R with respect to what? Gauge factor into del L by L. So that is what? My VB is equal to Vs into 1 by 4 into my gauge factor into del L by L. Now you know what to do. We have to just apply the values, and I give you 1 minute to find your gauge factor. We know VB, that is 1 millivolt, Vs 4 volt, gauge factor is to be identified, del L by L is given 100 microstrain. Now it's time to you try to do this. I'll give you some time to do it. Please try to calculate and give your answer in the chat. Are you trying or shall I try? Shall I solve it? $500 microstrain unit. It's a microstrain, but that's all. No issues, no issues. நீங்க அப்படியே அப்ளை பண்ணுங்க. அவங்க மெக்கானிக்கல் ஸ்ட்ரெயினோ இட் இஸ் மெக்கானிக்கல் ஸ்ட்ரெயின். del L by L தான் அவங்க கொடுத்துருக்கிறது. They haven't given del L separately. When I apply strain, அது என்ன ஆயிடுச்சுன்னா டிஃபார்மேஷன் ஆயிருக்குது. That is the whole del L by L is 500. It's a good question actually. சார் அவங்க மாத்தி கொடுத்துட்டாங்கன்னா எப்படி இருக்கும்? ஆக்சுவலி லென்த் கொடுத்துட்டு அந்த லென்த்ல எவ்வளவு மாறி இருக்குன்னு கொடுத்தாங்கன்னா we have to take both. Now luckily நான் I haven't taken depth. இது நான் ஸ்டார்ட் பண்ணாம நான் இனிஷியலா பேசிக் போறதுனால நான் கம்பைண்டா ஈஸியா இருக்கிற கொஸ்டின்ஸ் எடுத்துக்கிட்டேன். ஓகேவா? del L by L itself 500. Don't miss micro. அதுதான் பிரச்சனை. மைக்ரோ, this is M is milli. யூஸ் மைக்ரோ. அங்க அந்த தப்பு தான் நடக்கக்கூடாது. Very good. Answer 2. Anybody is getting anything else? Anyway, let me make for another second question. இன்னும் ஒரே ஒரு கொஸ்டின் காஞ்சில் ஃபினிஷ் பண்ணிக்கலாம் and then we will move on to the next topic. If they have given some options, நமக்கு அது இன்னும் கொஞ்சம் ஈஸியா இருக்கும். ஆப்ஷன்ஸ் இல்லைன்னா தான் கொஞ்சம் பிரச்சனை. So here the options are very easy to you all to identify. ஏன்னா you could able to find the answers. நான் எதுக்குமே ஆப்ஷன்ஸ் கொடுக்கல. I don't prefer it. So you could able to find the answers yourself. The answer is 2. Let us check. I quickly solve it. Are we getting the same? Let us check. So what is your voltage given? The voltage given is 4 into 1 by 4 into my gauge factor into 500 micro is 10 to the power minus 6. And the output voltage is, we got it like 1 millivolt. So you can directly solve this. When you solve this, milli will be cancelled with this. So you will get 10 to the power minus 3. And these two are cancelled. You will get 1. And here you check, I have 2 zeros. 2 zeros can be cancelled. So this will be 10 to the power minus 1. This is what? 5. So when I take 5 in denominator, 1 divided by 5 will be 0.2. So 0.2 is equal to, this is like 0.2 is equal to my gauge factor into 10 to the power minus 1. So this 10 to the power minus 1, when it comes over here, it will be 10. So what happens? So this is 2. Your gauge factor will be 2. Very good. So you could easily do it, no? Shall we have one more problem? 26. I think this adds some confidence level in you. So the same fashion you have to do. Proceed. See, we are giving the glitch. We are just initiating. So initiationல பிரச்சனை கிடையாது. இதை கண்டினியூ பண்ணணும். அங்கதான் we should withstand. Don't give up your time. You prepare on your own. Continue பண்ணிட்டே இருங்க. Because 4 hours, I don't think I can even cover some 2-3 topics. எனக்கு அது முடிச்சாலே பெரிய விஷயமா இருக்கும் 4 மணி நேரத்துல. So I will try to cover as much as possible. This is the question. Sorry. Okay, let it be. So let me also draw the diagram, because they have given it in diagram. Here they have taken 2 volt source and which is connected to a bridge. Let me have my bridge here, and this bridge is connected to the same resistance. Actually they're supposed to connect with the same resistance. The resistance values are 1000 ohm. They themselves have told it. The resistance values are 1000 ohm. They are 1000 ohm. 1000 ohm. So each 1000 ohm. I don't want to represent everything. each 1000 ohm. So this is similarly, it is open and we have the connectivity as 2 volt. The source is also 2 volt. Now, first let us make our connectivity. So what is given? The 1000 ohm strain gauge has a gauge factor of 2.5. GF கொடுத்துட்டாங்களா? டக்கு டக்கு நோட் பண்ணிக்கணும். We got GF given. One is given. It is connected in the bridge as shown in figure. அப்போ gauge factor எங்க கனெக்ட் பண்ணியிருக்கிறாங்க? ஏதோ ஒரு பாயிண்ட்ல கனெக்ட் பண்ணியிருக்கிறாங்க. That point which is missing, this point is missing. Okay. The strain gauge is subjected with the positive strain of 400 micrometer per meter. 400 micrometer per meter. Which means what is given? They have given del L by L. A micro strain is given, no? There it was 500, here it is 400. Pakka. Here it is 400. And what else given? We have to find the bridge output. V naught should be identified. இங்க கொடுக்காத ஒரு விஷயம் டயகிராம்ல இருந்து எடுக்கணும். என்னன்னு சொல்லுங்க பார்க்கலாம். One thing is not given in the sentence which is to be picked from the diagram. What is that? What is to be identified from the diagram? Okay, first let me write the equation. Maybe you might have confused. What is the output of this bridge? Very good. The V output, we have to identify the V output bar, not output. V output cannot be 0, no? So okay, let us check. V naught is V output, that is I am connecting with the quarter bridge once again. That is equal to what? My Vs. Since it is a quarter bridge, this is the formula 1 by 4 into del R by R. They are not given with del R by R. They are given only the strain, no? So this del R by R should be converted into del L by L. So let me make it as Vs into 1 by 4 into my gauge factor into del L by L. Excuse me. There is a problem with the board, so sometimes this may happen. Please bear with that. So here my Vs, what is Vs? Vs is not given, but it is given in the diagram. It is given in the diagram, so that is 2. So 2 is given, 2 volt into 1 by 4 into gauge factor is given in the sentence. What is the gauge factor? The factor is 2.5 into what is del L by L? Del L by L is 400 micrometer per meter. So you can cancel these two, micrometer per meter. When I cancel, what is happening over there? 10, and this is going to be 100, and you have 2 into 2.5. What is 2 into 2.5? 2 into 2.5. Tell me that alone. 2 into 2.5. 5 into 100 into what is micro? 10 to the power? 10 to the power? No? Oh, sorry. Yeah. Micro is 10 to the power minus 6. Right. So now what happens? I will cancel two things. So this will be 10 to the power minus 4. 5 into 10 to the power minus 4 voltage. So that is equal to 0.5, which is given 1. 1 is given. When 1 is given, into 10 to the power minus 3 volt. How it stands for? எப்படி எழுதலாம்? 0.5 into 10 to the power minus 3 volt is equal to millivolt. But அவங்க எப்படி கேட்டிருக்கிறாங்க? What is asked? Which means what we have to write? Tell me what we have to write. Up to 2 decimal places. When they ask like that, how many decimal places I supposed to make? I supposed to make 2 decimal places. So this itself a right answer, and you can write it like up to 2 decimal places. You have to make it like this. They themselves asked it in terms of millivolt. இல்லனா இங்க கன்வர்ட் பண்ண வேண்டிய அவசியம் கிடையாது. You don't need to convert this. Right? It is 0.5. You don't need to convert this. Why I am converting this? They have asked in terms of millivolt. Keep that in mind. Millivolt and 2 decimal places. Conversion is very easy. Now, is that clear? Is that clear? Good. Do you need a break or shall I continue? Good. So now I would like to add 2 notes for this. When there are questions in your gauge or 2-3 addition மட்டும் வெச்சுக்குங்க. That is like a hint to you. So the gauges, that is, when I apply strain, there will be a deformation which leads to a deformation in my electrical quantity, that is resistance la change இருக்கும். ரொம்ப ஈஸியான கான்செப்ட் தான். ஒரு you have a pipe, you are pouring some water. நீ பைப் பிடிச்சி தண்ணி பாய்ச்சுற மாதிரி தான். தண்ணி பாய்ச்சுற பைப்பு பெருசா இருந்தது பம்ப் செட்ல அப்படின்னா வாட்டர் ஃப்ளோ நிறைய இருக்கும். சின்ன பைப்பா இருந்தா வாட்டர் ஃப்ளோ கம்மியா இருக்கும், ப்ரெஷர் அதிகமா இருக்கும். அவ்வளவுதான் டிஃபரன்ஸ். ஓகேங்களா? தட் ஃபேக்டர் இஸ் டிபெண்ட்ஸ். ஸோ என்னுடைய ஸ்ட்ரெயின் காஜ், ஜென்ரலா ஸ்ட்ரெயின் காஜ் ஆர் மேட் அப் ஆஃப் 2 things. எனக்கு conductivity is most important. So is it possible to develop a strain gauge by using a insulator? My first question is, strain gauge insulator வெச்சு define பண்ண முடியுமா? Is it possible? What is an insulator? Insulator is a non-conductor. What is the resistance of an insulator? What will be the resistance of the insulator? என்னவா இருக்கும் ஒரு இன்சுலேட்டருக்கு ரெசிஸ்டன்ஸ்? இன்சுலேட்டரோட ரோல் என்ன? இட் ஷுட் நாட் பாஸ் த கரண்ட். அது வழியா சோர்ஸ் பாஸ் ஆகக்கூடாது. அப்படி பாஸ் ஆகக்கூடாதுன்னா த இன்சுலேட்டர் ஷுட் ஹாவ் த ஹையர் ரெசிஸ்டர் வேல்யூ. எப்படி இருக்கணும்? இட்ஸ் ஆல்மோஸ்ட் ஈக்குவல் டு இன்ஃபைனைட். அக்ரி? இன்சுலேட்டருக்கு இன்ஃபைனைட் ரெசிஸ்டிவிட்டி இருக்கும். பட் வாட் இஸ் த கேரக்டர் ஆஃப் மை ஸ்ட்ரெயின் காஜ்? ஸ்ட்ரெயின் காஜுக்கு என்ன கேரக்டர்? நான் ப்ரெஷர் அப்ளை பண்ணும்போது இட் ஷுட் லீட் டு த அவுட்புட் ஷுட் சப்போஸ் டு கிவ் மீ த சேஞ்ச் இன் ரெசிஸ்டன்ஸ். அப்போ இன்சுலேட்டர் இன்ஃபைனைட் ரெசிஸ்டன்ஸ்னா டினாமினேட்டர்ல இன்ஃபைனைட் இருக்கு. அப்ப நியூமினேட்டர்ல இங்கேயும் ஒரு பாயிண்ட் இருக்கு சான்ஸ் இருக்கா? நாட் அட் ஆல் பாசிபிள். ஸோ இன்சுலேட்டர் cannot be made by using strain gauge cannot be made by using insulator. அப்ப இது எதை வச்சுதான் அவங்க மேக் பண்ணணும்? What is the manufacturing principle? They're supposed to use two things. That is conductor. They should use conductor. That they are making it as one is a conductor, another one is a semiconductor. One is a conductor, another one is semiconductor. The two use பண்ணி தான் strain gauge they will do. When they use conductor like a metal or something, ஒரு conductor use பண்ணாங்கன்னா the gauge factor will be between 2 to 3.5. அவ்வளவுதான் இருக்கும் approximate. Maybe with respect to practical constraint the gauge factor may differ. கொஞ்சம் முன்ன பின்ன இருக்கலாமே ஒழிய இட்ஸ் லைஸ் இன் திஸ் ரேஞ்ச். தேர் will not be any negative. Carefully checking, there will not be any negative gauge factor. But if it is made up of semiconductor, semiconductors, what you know? You know germanium, silicon, right? So these are all some types of semiconductors. Silicon, germanium. We are manufacturing ICs, no? That is made up of, ICs are made up of semiconductors. So that is what you should keep it in your mind. This may have a gauge factor in negative sign. Minus 100 la ஆரம்பிச்சு 250 வரைக்கும் போகும், up to 250. அப்போ கொஸ்டின்ல if they are representing anything specific like metal or a conductor, gauge factor in the range இருக்காங்கிறது உங்களுக்கு ஒரு clue. This is a hint. This cannot be the answer at all the time. மைண்ட்ல வச்சுக்கங்க, this is an hint. ஒரு ஐடென்டிஃபிகேஷனுக்காக யூஸ் பண்றதுக்காக மட்டும் தான் இந்த hint. ஓகேவா? Okay. Now let us go with the next topic. So that is okay, sir. I use my resistor to identify the force. ஒரு ஃபோர்ஸோ ஒரு ஸ்ட்ரெயினோ அப்ளை பண்ணால் how far it is changing and how it is benefited to me to understand the physical changes. எங்கே யூஸ் பண்ணுவாங்க? நிறைய இடத்துல யூஸ் பண்ணுவாங்க சார். திஸ் இஸ் a most important one. இப்போ அதே ரெசிஸ்டிவ் டிரான்ஸ்டியூசர்ஸ் ஆர் லாட் மோர், நிறைய இருக்கு. நிறையெல்லாம் போக வேண்டாம். ஐ வில் டேக் ஒன்லி ஃபியூ. ஸோ ஐ எம் கோயிங் டு பிக் temperature as a parameter right now. We have another 40 minutes. I have LVDT is a wonderful concept. Okay, 40 minutes, temperature is fine. Not LVDT, temperature is fine. We'll go with the temperature. Okay, let me cover some theory behind it, because each and everything is needed with certain basics. Temperature. What are all the various temperature measurement you use? Like what are all the transducers you use to measure the temperature? சரி, இதெல்லாம் யூஸ் பண்ணலாம். உங்களுக்கு தெரிஞ்ச ஒரு 2-3 சொல்லுங்க, நிறைய வேண்டாம். 2 or 3. At least 1 or 2, not 2, 3 and all. 1 or 2. That is sufficient. Temperature measure பண்றதுக்கு நம்ம யூஸ் பண்ணலாம் சார். LM35 you generally use LM35. உங்க ப்ராஜெக்ட்ஸ்லாம் பார்த்தீங்கன்னா சின்னதாக ஒரு பிளாக் கலரில் ஒரு டாட் வச்சு ஒரு விஷயம் இருக்கும். LM35 we are using, no? So that is also a temperature sensor, and which is to be connected with some electrical circuit where we do the conversion and all. நிறைய அங்கே பண்ணிக்கும் conversion எல்லாமே, we will do it at that point. So it is like we will be going, but here in your gate, this temperature specifically we used to measure because we are targeting industrial instrumentation. Right, அதுதான் நம்ம யூஸ் பண்ணிட்டு இருக்கிறோம். ஸோ தீஸ் ஆர் ஆல் த சென்சார்ஸ் தட் தே ஆர் யூசிங் இன் இண்டஸ்ட்ரீஸ். ஆர்டிடி, தெர்மிஸ்டர் அண்ட் தெர்மோகப்பிள். RTD, thermistor and thermocouple. Not only restricted with these three, but நான் இந்த மூணு ஸ்பெசிஃபிக்காக எடுத்திருக்கிறேன். Why? Because these three are some good relationship. மூணுமே மூணு டைப், அதுக்காக தான் நான் இந்த மூணு ஸ்பெசிஃபிக்காக எடுத்திருக்கிறேன், வேற ஒன்றுமே இல்லை. ரைட்டுங்களா? இட் இஸ் நாட் தட் வி ஹாவ் டு பிக் த சேம். இந்த மூணு எடுத்ததுக்கு காரணம் அதுதான், இந்த மூணுமே மூணு டைப். ரைட்டுங்களா? லெட் மீ டெல் யூ த working principle for all these three. Right? So let us make it as working principle. So these three are different in their working principle. This RTD is positive temperature coefficient resistor, and this is negative, and this is working based on the Seebeck effect. So I'm going in parallel with all these three because I may not be able to cover much more things. So I would like to cover the basics. எனக்கு இருக்கிற டைமுக்கு நான் கவர் பண்ணும்போது இந்த மூணுத்தையும் பேசிக்ஸ் ஒன்னா படிச்சீங்கன்னா யூ வில் பி பெட்டர். ஸோ ஆர்டிடி, தெர்மிஸ்டர் அண்ட் தெர்மோகப்பிள் மூணுத்துக்கும் இருக்கு. ஒன் இஸ் பாசிட்டிவ் கோஎஃபிஷியன்ட், another one is negative temperature coefficient, last one is with respect to Seebeck effect. So what is positive temperature coefficients? Very simple, sir. Very simple. When my temperature increases, what will happen to my resistance? My resistance will also increase. These things which will help you to predict the answer, not to solve the answer. Or some logical informations, it will help you to predict the answers. So that is why I am stressing on that, because you may be new to temperature measurement. எதை யூஸ் பண்ணணும் அப்படிங்கிறது ஒரு விஷயம், அதை எப்படி யூஸ் பண்ணணுங்கிறது அடுத்த விஷயம். You can use n number of sensors, n number of transducers, but if you want to find a resistor, டைரக்டா நம்மளால டெம்பரேச்சரை மெஷர் பண்ண முடியாது. We have to find only through the resistor. அப்போ when I have high temperature and I am capable enough to measure the high resistance, I will be going with RTD. இண்டஸ்ட்ரியில தான் நடக்கும், அதிகமாக இதான் நடக்கும். ரைட்டுங்களா? செகண்ட் ஒன், negative temperature coefficient, which means when the temperature increases, what will happen to my resistor? It will decrease. அப்ப எப்படி இருக்கும்? If I draw it in graph, you see, so this is temperature and this is resistor, and this will linearly goes with respect to temperature or resistor or linear இருக்கும். That is the matter. What will happen to my thermistor? Thermistor எப்படி இருக்கணும்? It's supposed to be non-linear. It should be non-linear. Temperature as well as resistor, if I take, it's supposed to be non-linear like this. But என்ன ஆகுனா, thermistor is non-linear, linear எல்லாம் போகாது. It will be like exponentially decaying. இதுதான் விஷயம். ஓகேங்களா? And அப்போ எனக்கு what is the nature of my temperature sensor? You got to know. What is the nature? You got to know. Excuse me, 1 second. You got to know, right? So now what is the temperature transducer is all about? இங்க பாத்தீங்கன்னா எப்படி இருக்கும்? Here temperature increases, resistance increases. So how to find this? We have to connect with the external source. ரெண்டுத்துக்குமே positive temperature coefficient, negative temperature coefficient, both we need to connect with some external sources. So this is under passive transducers. These two are under passive transducers. Right. So feedback effect, this is active transducer. Right, like piezoelectric sensor, thermocouples, solar cells, pH electrodes. So இதெல்லாமே பார்த்தீங்கன்னா comes under active transducer, which is not required any external sources. But these sensors will be in need of one particular external sources. Okay, so now let us go like this. ஒரு டெம்பரேச்சர் இருக்குது. Based on the temperature, I would like to identify the characteristic. அது vary ஆகும் சார். It is varying and it can be RTD, which means positive temperature coefficients. Thermistor means negative temperature coefficients. Also I can go with Seebeck effect. Right. So now I would like to make it with respect to one particular problem. Or problem நம்ம define பண்ணி we will try to find the solution. A thermometer at room temperature எப்படி இருக்கும், ஒரு எஃபெக்ட் எப்படி இருக்கும் அப்படிங்கிறதுக்குனால ஒரு சிம்பிள் பேசிக் கொஸ்டின்ஸ். ஐ எம் நாட் கோ இன் டெப்த், ஐ எம் டேக்கிங் ஒன்லி தி பேசிக் கொஸ்டின்ஸ் பிகாஸ் யுவர் டெம்பரேச்சர் சென்சார்ஸ் வில் நாட் டைரக்ட்லி டேக்கன் இன் டு அன் அக்கௌண்ட். இட்ஸ் சப்போஸ் டு கனெக்ட் வித் ஆப்பர். உங்களுக்கு ஆப்பாம் கொஞ்சம் நடத்திருக்கணும், ஆப்ரேஷனல் ஆம்பிளிஃபையர்ஸ் நடத்திருக்கணும். ஐ டு நாட் நோ வெதர் தே ஹேவ் டச்ட் அப்பாம். ஆப்ரேஷனல் ஆம்பிளிஃபையர் நடத்தியிருந்தாங்கன்னா ஐ கேன் சால்வ் சம் மோர் ப்ராப்ளம்ஸ். ஸோ சின்ஸ் பிகினர் டு கேட் ஆப்பம் யூஸ் பண்ணி ப்ராப்ளம் சால்வ் பண்றது நமக்கு இப்போ வேண்டாம். We will go only one. I'll give you the basic question. So I have a thermometer. Let us assume thermometer. One second, let me type it. ரொம்ப ரொம்ப முக்கியமான கொஸ்டின்னு சொல்லணும். பிகாஸ் this takes our regular life equation. Question is typed in the chat. I also project it in the screen. ரொம்ப basic questions, but it is like a direct questions. Yeah. A temperature at room, a thermometer at room temperature 30 degrees is dipped suddenly into the bath of boiling water 100 degree. என்ன பண்றோம், ரூம் டெம்பரேச்சர் 30 டிகிரில இருக்கிற ஒரு டெம்பரேச்சர் எடுத்துக்கிறோம், தட் இஸ் தெர்மோமீட்டர் எடுத்துக்கிறோம். அது என்ன காட்டிட்டு இருக்கும், இட்ஸ் சப்போஸ் டு ஷோ த சேம் 30 டிகிரி செல்சியஸ். இட்ஸ் சப்போஸ் டு சே டக்குன்னு என்ன பண்றேன், ஐ எம் கோயிங் டு கீப் இட் இன் த பாயிலிங் வாட்டர் விச் இஸ் அண்டர் 100 டிகிரி செல்சியஸ். இப்போ 100 டிகிரி செல்சியஸ்க்குள்ள டக்குன்னு உள்ள வச்சிடறேன். அப்போ வச்ச உடனே டெம்பரேச்சர் என்ன ஆகும், இட் வில் ட்ரை டு இன்க்ரீஸ் ஃப்ரம் 30 டிகிரி டு 100 டிகிரி. அந்த 30 டிகிரி டு 100 டிகிரி இன்க்ரீஸ் ஆகிறதுக்கு when it reaches, let me draw it. Initially எனக்கு எங்க இருக்கு, it is at 30 degree Celsius. ஓகேங்களா, the temperature is at 30 degree Celsius. I supposed to reach 100 degree. அப்ப இங்க 100 degree reach ஆகிறதுக்கு it is taking some time. No, it is taking some time. So at t is equal to 0 I am starting. In the time it takes 96.5 degree Celsius reach ஆகிறதுக்கு it takes 30 seconds. 90 degree 96.5 degree reach ஆகிறதுக்கு it takes 30 seconds. அப்ப என்ன கேக்குறாங்கன்னா 96.5 reach ஆகிறது 30 seconds னா 98 reach ஆகிறதுக்கு எவ்வளவு நேரம் ஆகும்? That is the question. That is the question. The options are given. I would like to project the options for you because the options which will help you to identify டைரக்டா போறதுக்கு கொஞ்சம் யூஸ்ஃபுல்லா இருக்கும். 32.5 seconds. Number 2, 34.6 seconds. And option C, 35.6 seconds. Option D, 38.6 seconds. கொஞ்சம் காம்ப்ளிகேட்டடான விஷயம், ரைட்டா? You take this, right? So temperature coefficient, when I use transducer, you might have studied one particular formula. Your final output plus difference in your output. Initial output la irundhu final output varadhukku difference with respect to T by tau. Tau is the temperature coefficient, T is the time period, and your output will be with respect to this particular. This is for every thermometer equation. We supposed to go with this particular formula. So the formulas எல்லாமே உங்களுக்கு முதல்ல இருந்தே தெரிஞ்சிருக்கணும். So I am directly giving you the formula. Temperature க்கு we will be using this formula at most of the cases along with your op-amp equation. Operational amplifier ideal op-amp இருக்கும், maximum ideal op-amp கொடுப்பாங்க, sometimes it may differ. So op-amp equation should be known, right? RTD equation should be known, thermistor equation should be known. The equations எல்லாமே உங்களுக்கு தெரிஞ்சிருக்கணும். Here in this particular problem we are using only this particular formula, right? So we have to directly apply the values to find your informations. So here the problem is the temperature coefficients are not given, but the values are given, right? How it is given? This is for your voltage. I have to convert the same. அவ்வளவுதான் சார், வேற ஒண்ணுமே இல்லை. இதுல மட்டும்தான் you should be very very cautious. வோல்டேஜ்ல கொடுத்திருக்கிறதுக்கு நம்ம என்ன பண்ணணும்? நமக்கு என்ன கொடுத்திருக்காங்க? They have given the values in terms of temperature, so we have to make it with respect to T. So the same thing I am converting. My temperature will be T final plus, so T initial minus T final into e to the power minus T divided by tau. That's all. So this is what we have to do it on our own, right? So I am just going to do the remaining ellame just a formalities. It's very very simple. It's just a formalities. So what I know from the equation, from the given question, I have to take it, no? So first at initial stage, I am reaching 96.5 degrees Celsius in 30 seconds. This is one information I got to know from the given question. Second one is how much time I will take to reach 98 degree. இது ரெண்டு தான் என்னுடைய information which I got it from the question. So first one, let me take, I got my temperature, that is 96.5. I got my temperature, that is 96.5. What is the final temperature? At last, where I will go? The temperature of my water in bath is 100 degrees Celsius. So the final value is 100 plus, what is your initial value? What is your initial value? It is actually at room temperature, that is 30 degree. From the graph, you know, from the graph you got, no? Excuse me. So from the graph you got, no, that is 30 degree. So the initial value is 30. Once again the final value is 100 into e to the power minus 30 divided by tau. Oh, I do not know the value of tau. எனக்கு என்ன ஆயிடுச்சு? டவ்வோட வேல்யூ தெரியாது. So when I solve this particular equation, I'll get to know the tau. அப்போ இந்த particular point ல இருந்து I'm getting tau. So after that, what I can do by using this particular point, 98 degrees Celsius will be your temperature, right? It will be your temperature. You know the final value, you know the initial value, you know your 100 degree e to the power minus t தெரியாது because you wanted to find the t, you do not know the t, but you got to know about the tau from this particular equation. You redo the same, you will get your time. That's all, sir. This is what we are going to make now. So nothing to worry. You need a calculator. Calculators are restricted in GATE. It is not that you should not bring the calculator. You can bring only certain type of calculator. அதுதான் நீங்க மைண்ட்ல வச்சு எடுத்துட்டு போகணும். When you solve this, you will get your tau. Please you try to solve this to find the tau. Try to find the tau. Okay. Let me do it. So this is 96.5 is equal to 100. 100 when you take it to your right hand side, this will be helpful to you. Get subtracted 96.5 minus 100 and you will be finding this as minus 70. And when you do, you will get your tau as directly. Let me make it just to verify your answer. Tau will be equal to around 1.12. It will be around 1.12. When you consider the same, sorry, not around 1.12, 1 second. Sorry, tau is around 10 point something, it will be around 10. So it was like 10.012 and let us make it some two fractional value alone. Tau is around 10. So with respect to this particular state, so 98 degrees Celsius, when I take it as my temperature, again you have to apply your remaining things, that is your final value is 100, your initial value is 30, your final value is 100 e to the power minus t divided by your tau is 10.01. So here you do not know only t. When you take your t, you will get your answers. So I am substituting my tau from the previous equation and I would like to find the time taken to reach my temperature 98 degree, right? Though the starting point is at 30 and my ending point is 100. So you should know all this information. Now when you apply, you will be able to find your t. Let me wait. If anybody could be able to identify, you post your answer in the chat, or otherwise I will post the answer in the chat. I think this seems to be boring to you all because I could not see any response in the chat. Solving problems around 4:15 is tedious, no? So okay, let me complete this. It is 35.3 seconds. Skip this. Let us go for the interesting theory. Let us change our topic. Let us have some interesting theory. You solve this, no? You solve this equation and you get tau, no? Using calculator, please do it. Right. As of the responses are reduced, I would like to move on to the next one. Very interesting. So this is once again an important concept. Linear variable differential transformer. So how the transformers are? We will go the theory because I don't want to go with the mathematics now. People may sleep. What is transformer? Generally, the transformer will have two winding. Generally, let us go one by one, sir. Let us go one by one. Linear variable differential transformer. Right? Linearly varying equipment, that is your transformer. What is your transformer? A transformer is the one which converts. A transformer is the one. Let me take the transformer image for your representation. So I will have two winding one and winding two. I will have two winding. The windings, one is primary winding, another one is secondary winding. I have two windings. So what it do, it directly proportional to each other. You may give some source, you may give some source, so which will be transformed from this point to this point. The winding will transform the energy. Right? This is what they are taking it as a transformer. So this transformer should be a differential transformer. This transformer should be a differential transformer. How it is being achieved? So let me tell that how it is achieved. You see, they are going to connect two windings. They are going to connect two windings in series opposition. Series opposition means what? Let us take it into an account. When these two windings are connected like this is winding number 1 and this is winding number 2. For understanding, I would like to have this as positive side and this as negative side. Positive side, negative side. When I connect these two like this, when I connect these two like this, which means series. Please carefully check in, which means series. When I connect like this, which means once again series, but positive should be connected to negative, but I did not connect like that. I am connecting the positive to positive, negative to negative. It's similar to parallel, but actually it's a series. So that is what we call it as series opposition. So this is series opposition. So where I will take the output, I will take the output between these 2 points. I'll take the output between these 2 points. So which we call it as, with respect to time, My voltage is passed to this winding, but luckily this has to be transferred over here, no? So when I pass, there will be an electromagnetic flux which is supposed to be induced from this coil to this coil. So that electromagnetic flux which is supposed to help to transfer that, I will be using a core in between. I'll be using a core in between. Sorry. So this core is generally made up of ferromagnetic material. This is a core. This core is generally made up of ferromagnetic material. Excuse me. Sir? சொல்லுங்க. Sorry. So this is made up of ferromagnetic material. So ferromagnetic material. This is made up of ferromagnetic material. What happens? You see, when the source is connected to this particular winding, it will induce some flux. It will induce some flux. That flux is represented as phi 1 here, and this flux which will produce an EMF over here. So this which will help you to obtain some EMF. Let me make it as ES1. Similarly, this will induce one more EMF right here. No, that let me represent it as ES2. Right, this can be sometimes you can also represent by using voltage. That is not a big deal. Okay, so we will have a source which is connected through the primary winding, and in the secondary winding we will be getting to induced EMF. Now, since it is connected in series opposition, actually they are symmetrical to each other, sir. That you supposed to very much conscious. So these two are symmetric to each other, but they are connected in series opposition. So what happens when I connect in series opposition? The output will be the EMF. What I'm getting will be the difference between these two. That is the matter. The difference between these two will be equal to ES1 of T minus ES2 of T. So if I am connecting this in series, if I am connecting these two windings in series, the same will not be, this will not be the difference, this will be the sum. Actually, the output will be the ES1 of T plus ES2 of T. That will be the sum. Sir, why can't I take it as a sum by connecting them in series? அதுதான் விஷயம். I'll tell you with a small example. I tell you with a small example. See, let us assume the same. So this is ferromagnetic material we have as a core. No, this I would like to connect with one water tank. So this core, which I would like to connect with one water tank, and this is my water level. We assume this is your water level. Now, this is directly connected to the floating point. I have a floater which is floating on the water, and this is connected over my ferromagnetic material. So what happens here? What happens here? Let us assume when the water level increases, the ferromagnet will move towards upside. So for this, we would like to take another one thing, that is, this is directly connected with this. This is directly connected with this, not this one. Not this one. I am taking the red line, not this one. This connection is not available. We are directly connected. So the output among these 2 points is what we are going to consider right now. So if it is directly connected, what happens? So I will be getting one EMF on the secondary winding, one EMF on the secondary winding, first winding. So what happens? My entire equation will be turned into the entire equation, that is E output will be turned into ES1 plus ES2. So when the core is directly involved only in the first winding, when the water rises, the core will be involved in the first winding alone. The secondary winding will deliver zero. The secondary winding will deliver zero, which means your raised water level will be producing an E naught like ES1 plus 0, which will be equal to ES1. Now, in the second case, let us assume the water is decreasing. When the water decreases, what happens? Your E naught will be, when the water decreases, your core will move towards your secondary winding. The primary winding will deliver 0, but the secondary winding will deliver ES2. So, which means this will be 0 plus ES2. So, this is once again which will deliver. The both are in positive. So, we do not know the both will deliver the positive node. Both will deliver the positive amplitude. So which will not help you to identify whether it decreases or increases. Whether it decreases or increases, that you do not know. அதனால தான் என்ன பண்ணியிருக்கிறாங்க, they are taking a series opposition connection. When I take series opposition, this is connected like this. So I will take the output across this. So by the time what happens, when your water level increases, primary winding alone will deliver. That is secondary winding. In that first winding alone will deliver. So which leads to E output as ES1 minus 0, which is equal to ES1. But when the water level decreases, what happens? This ferromagnetic core, which will be coming to the second winding. So by the time the E output will be 0 minus ES2, which will be equal to minus ES2. Right? The positive node, which means increasing in one direction, negative node, which means decreasing in another direction. That is what you should be very, very cautious. So that is why the LVDT is connected in series. The LVDT connected in series, but opposed to each other. Positive is connected in negative direction. Negative is connected in positive direction. Series opposition. So the this core we have in between two windings now. This is made up of ferromagnetic core. This is your primary winding. This is your secondary winding. There are some basic questions, sir. Very very basic questions which was asked in GATE. நீங்க ரொம்பலாம் காம்ப்ளிகேட் பண்ணவே வேண்டாம். ரொம்ப 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 basic questions. I think in 2010 I noticed about LVDT. The moving core, the what they are meaning, the moving core of your LVDT is made of dash material. It was a question. The moving core of your LVDT is made of dash material. So that was one question asked in the GATE 2010 or 11. I am not sure about the exact points. I will deliver two things. With that, we will complete our today's session. I will deliver two questions. First question is, the moving core is a dash material. This is the first question. It is ferromagnet. The second question. From the theory, I thought you know. I'm just giving it. So they have given it like these two are the gate questions. The primary moving coil, I told you know, this is ferromagnet, and here the linear variable differential transformer, they are meaning LVDT. That's all. The LVDT actually we have one primary coil, two secondary coil. So directly this tell you about your information. You see, two primary coil, it fails. Two primary coil, which means this fails. Two primary coil connected in phase and a secondary coil. One secondary coil. No, we have two secondary coil. We know the LVDT should have one primary coil, two secondary coils. Similarly, two primary coils are connected in opposition. No, I have only one primary coil. This is fails, and a secondary coil. Of course, I should have two. One primary coil. It is right. One primary coil and two secondary coils are connected in phase. No, they are not connected in phase. They are connected in opposition. Right. Third one the primary coil and two secondary coils connected in opposition. This is once again a gate question. This is a theory, simple theory, which is noted here. Right. From here we supposed to make. So this let us make it with theory, and in the next class we will continue the problems. Right? Okay. Any doubts?
Sir, thank you, sir.
Yes, ma'am. Thank you, ma'am. We'll
Thank
wind.
you, sir. Thank you for your patience. நாளைக்கு கண்டினியூ பண்ணிக்கலாம்ல சார்?
Okay.
நாளைக்கு ஆஃப்டர்நூன் செஷன்.
After 10 to 30, right?
எஸ் சார்.
Okay, ma'am. Okay.
ஓகேங்க சார். தேங்க் யூ
Okay.
ஸோ
Thank you.
மச்.
Thank you.